It's an enormous pleasure for me to be here on behalf of the US Study Centre and to be associated with James Hansen's visit to Sydney. Let me give you just a very brief introduction of Dr. Hansen because I know you all want to hear from him rather than from me. James Hansen is an Iowan and a proud son of that state, receiving 3 degrees from the University of Iowa, a BA, an MS, and a PhD, all in physics. Since 1981, he has been director of the NASA Goddard Institute for Space Studies. Since 1985, he's also been in New York City, an adjunct professor of Earth and Environmental Sciences at Columbia University. In 1996, he was awarded the single highest honor that can be bestowed upon a scientist in the United States, which was his election to the National Academy of Sciences. In 2006, spreading the accolades around the globe, he was awarded for the World Wildlife Federation its Duke of Edinburgh Conservation Medal, 2006. Also in 2006, he was named by Time magazine as one of the world's 100 most influential people. And I think the popular acclaim for Dr. Hansen really is owed to the signature year of 1988, in which he led a team at the Goddard Institute, which for the first time published a scientifically credible study showing that our planet was warming. Later that year, he testified in some famous hearings in the US Senate, in the Congress, on global warming, influencing, I think at that time still, Senator Al Gore to become a passionate advocate of the issue, and leading Al Gore, Nobel Prize-winning former Vice President, former Senator Al Gore, to say of Dr. Hansen, "When the history of the climate crisis is written, Hansen will be seen as the scientist with the most powerful and consistent voice calling for intelligent action to preserve our planet's environment." Quite an accolade from Al Gore. In addition to his more publicly noted work, Dr. Hansen has written literally hundreds of articles in the world's leading science journals on the subject of tonight's presentation, and you'll see I just managed to flip through his PowerPoint deck. You're in for a significant educational experience on climate change, in addition to probably some pretty significant and interesting, I won't say controversial, remarks on the direction of climate change policy in the world today. In addition to all the articles that Dr. Hansen has written, he's also the author of a very recent book, which Meredith has already mentioned, Storms of My Grandchildren. Let me just read from the Los Angeles Times book review of that book. The LA Times said that the book was written by a scientist at the breaking point, the point at which he is willing to sacrifice his credibility to make a stand to avert disaster, to offer up the fruits of 4+ decades of inquiry and ingenuity just in case he might change the course of history. Indeed, people call Dr. Hansen, and since it's in the title of his book, I can say it without feeling at all strange about it, not the father of climate science, but the grandfather of climate science. 2 generations now of climate scientists obviously engaged in the global debate. Of course, he's anything but the cliche of what grandfatherly might connote for many of you. In fact, he's been an extraordinarily powerful public voice in the climate change debate, certainly in the last few months, saying some things that I think some of you might find quite interesting. I think in an op-ed piece in the New York Times in early December, that is before the Copenhagen Climate Change Summit, Dr. Hansen said it would be a good thing if the Copenhagen Summit failed. He also criticized Barack Obama and Kevin Rudd for thinking that emissions trading schemes were an important part of the solution to the climate change challenge. And he's been a long-term critic of the coal industry, I think presumably even including the new notion of clean coal, for its role in climate change. And of course, in Australia, I don't have to tell anyone in this audience that coal is Australia's #1 export earner to the world. I think only followed second by iron ore, also not doing a lot for the cause of climate change. So what we have tonight before us is a scientist of an extraordinary pedigree who has taken some of the boldest and most courageous stands in public one can think of. I couldn't be more pleased to welcome to the stage Dr. James Hansen.
Thanks very much. Thank you. Yeah, the debacle in Copenhagen, I think, actually, the failure to achieve an accord to reduce carbon dioxide emissions to the atmosphere, I think that could actually be helpful if we instead move toward an approach that is actually effective. So let me, in the last year or two, when I've given talks, I often start out by saying there's a large gap between what is understood about global warming and what is known about global warming. Understood by the relevant scientific community and known by the people who need to know, and that's the public and policymakers. Now, incredibly, in the last 6 months, that gap has widened noticeably. The science has crystallized, has become clearer. Some of the issues that were still loose ends at the time I was writing my book have been clarified in the last 6 months, and yet the public's perception of the issue has become less certain, as in part due to the fact that the people who prefer to continue business as usual have perpetrated a great hoax on the public, which I will come back to in a few minutes. The truth is that it is clear that we have a crisis, a planetary emergency. And it's hard for the public to see this because the climate change, global warming, is small in comparison to weather fluctuations from day to day. But one of the reasons that it is a crisis is that the climate system has tremendous inertia, due in part to the ocean, which is 4 kilometers deep, and the ice sheets, which are a couple of kilometers thick. These respond only slowly to changes in the forcing mechanisms that humans or nature applies to them. So as a result, the planet, because of the large thermal inertia of the ocean, has warmed only about half as much so far as it will eventually due to the gases that are already in the atmosphere, let alone those that we're continuing to add every year. And the problem with that is that the climate system has tipping points. You can push the system beyond a point where the dynamics of the system begins to take over and you begin to get relatively rapid change, which is out of control of humanity. The bad news is that what has become clear is that the safe level of atmospheric carbon dioxide is no higher than 350 parts per million. and we've already caused it to increase from 280 parts per million in the pre-industrial atmosphere to almost 390 parts per million now. But the good news is that it is still possible to go back to less than 350 ppm. And there are other reasons why that makes sense and other advantages of doing that. Now, just to say a few words about tipping points. One of them is in the case of ice sheets. For example, if an ice sheet begins to, if it reaches the point where it's beginning to disintegrate and large portions of it sliding toward the ocean, well, by that time it's too late. You can't tie a rope around an ice sheet, which is a couple of kilometers thick. And the way that works is the most important process seems to be the warming of the ocean. As it gets slightly warmer, it begins to melt the ice shelves, which are the tongues of ice that reach out from the ice sheets into the ocean, go under the ocean water. Those ice shelves around both Antarctica and Greenland are melting now at a rate of several meters per year. And as they melt, that allows those ice shelves buttress the ice sheet. And so as they disappear, then the ice streams, the more plastic parts of the ice sheet, move more rapidly and discharge icebergs to the ocean more rapidly. And they can reach the point at which the ice sheet begins to disintegrate. Another tipping point is occurs in the case of the extermination of species. As the climate zones shift, it begins to put pressure on species. We're putting pressure on species in a number of different ways, but one of the most important is the climate change that is beginning to be consistent and cause a given isotherm or temperature line to move poleward at a rate of about 60 to 70 kilometers per decade for the last 3 decades. And at first, this is not a problem, but as that continues and goes faster, then the climate zones are moving rapidly, and species can only live within certain climate zones. So they, some of them will be, which cannot migrate rapidly, will go extinct. And as some go extinct because of the interdependencies among them, whole ecosystems can begin to collapse. And this is not a hypothetical thing. We know that it's happened during the Earth's history, during large global warming. Several times in the Earth's past, there were mass extinctions of half or more of the species on the planet. And then over hundreds of thousands and millions of years, new species came into being, but for any time scale that humans could imagine, we would have a much more desolate planet if we drive a species to extinction. Now, I want to emphasize the intergenerational injustice, inequity in in human-made climate change. This is my first grandchild. I started to show this photo initially because the newspaper had called me the grandfather of global warming, and I wanted to show I really was a grandfather. And it wasn't, I didn't immediately, it wasn't, you know, after testifying in 1988 and 1989, I realized that that public stuff was really not my cup of tea, and I preferred to do science, and I decided to get out of the public aspect of this. And when I got interview requests from the media, I would refer them to a couple of friends of mine, Steve Schneider and Michael Oppenheimer, who were articulate and they enjoy that process. And so for 15 years, I maintained that resolve until 2004, the middle of the Bush administration, by which time it had become clear that the government, our government, was not doing anything to address this issue. And furthermore, they were actually censoring science, trying to prevent the public from understanding the full nature of it. And so I decided I was going to give one talk and try to prepare that carefully and the papers to back it up, and rationalize that by saying I didn't want my grandchildren to say Opa understood what was happening, but he never made it clear. Because eventually the people in the future are going to look back on this age and say, why didn't, the science was becoming clear, why didn't you do something? Our understanding of global warming, climate change, it's often said it's based on climate models. That's not really true. The most important and detailed information that we have about how sensitive the system is and how it will respond as the boundary conditions change, including the atmospheric composition, comes from the history of the Earth. We have detailed records of how the Earth responded in the past to those changes. And also, second on the list is the observations of what is happening now. We now have satellites, we have ways of measuring accurately how many things are changing in response to these rapid changes in atmospheric composition. And climate models help also. Now, I'm not going to, I would love to talk about paleoclimate, but I'm going to do only a little bit of that because it's 45 minutes doesn't give me too much time to do too much paleoclimate, but I will do a little. Now, one thing in terms of what's happening now, we began to make satellite observations of the sea ice in the Arctic in the late 1970s, and what we see is that the amount of sea ice fluctuates from year to year depending on the weather that year in the Arctic. But there's a strong downward change in the amount of sea ice. It's decreased by more than 30% over the last few decades, and within 20 or 30 years, we will probably lose all of this ice in the warm season at the end of the summer. And that raises questions about the stability then of the Greenland ice sheet and the stability of the frozen methane that's on the continental shelves off the coast of Canada and Siberia. Another thing that we're observing is the melting. We can observe from satellite is the area that has summer melt on Greenland. And that too, as shown by the line graph, it fluctuates a lot from year to year depending upon the weather that summer. But you can see that there is a trend toward more and more larger and larger area with summer melt. And that meltwater does not make it to the edge of the ice sheet in general. It burrows a hole in the ice sheet and goes to the base of the ice sheet where it lubricates the ice sheet and causes these giant icebergs to be discharged to the ocean more rapidly. We didn't know for sure what the impact of this warmer climate was on the ice sheets because increased temperature also causes the atmosphere to hold more water vapor. So there's more snowfall in the winter, which makes the ice sheet thicker. But common sense tells you that as the planet gets warmer, the ice sheets are probably going to get smaller. And now, beginning in 2003, we began to measure with the gravity satellite, GRACE, which measures the gravitational field of the Earth with such a high precision that we can accurately track the mass of the Greenland ice sheet and the Antarctic ice sheet. And the ice sheet gets heavier in the winter as the snow piles up, and it loses mass in the summer. But you can see it's losing mass overall at a rapid rate. And what is particularly important is the recent update to these curves, adding the last 2 years of data, makes it clear that the rate of mass loss is actually increasing. Greenland was losing mass at a rate of about 150 cubic kilometers per year. Well, it's now about 250 cubic kilometers per year. And Antarctica was losing mass at a rate of about 75 cubic kilometers per year. Now it's about 150. So there's been almost a doubling in just several years. Another expected effect of global warming is an expansion of the subtropics as the rising motion that occurs at the equatorial region and the subsidence that occurs at somewhat higher latitudes, which causes the existence of the subtropics. That circulation cell is expected to expand as the planet gets warmer. And what we observe empirically is that it has expanded by about, on average, around all longitudes, on average it's expanded by about 4 degrees of latitude. And that's already beginning to affect regions like the southern United States, where Lake Mead and Lake Powell are now only half full, and the Mediterranean region, and I would say it's also affecting Australia, because it causes the jet streams to move slightly poleward. And of course, that doesn't mean that and by the way, another impact of this increased dryness is an increase in the fires, which is noticeable. There are other factors that affect the fire frequency and intensity, but there is a tendency for fires to burn hotter as the planet is getting warmer and drier in these regions. And there are other factors that affect rainfall. So, for example, the ocean temperature patterns, the ocean temperature in the Indian Ocean and the El Nino, La Nina oscillation in the equatorial Pacific, and the temperature of the waters around Australia will all influence rainfall in Australia. And in general, because the ocean waters are getting warmer, you're going to get, when you do get rainfall, you can get heavier events, more extreme rainfall events. But overall, when you average over decades, you're going to see, I think, a more intense subtropical type climate in much of Australia, and that's an effect of global warming. Another thing that's happening is all around the planet, glaciers are melting. And by the way, here's a case where you probably heard, this is part of what I call the great hoax. In this telephone-thick IPCC report, there was a mistake with regard to Himalayan glaciers. It said Himalayan glaciers would be gone within 25 years. That's not true. The Himalayan glaciers are the highest and the thickest on the planet, and they're not going to melt that rapidly. But the main point is that glaciers are melting all around the planet, in the Rocky Mountains, the Andes, the Alps, the Himalayas. We have a national park in the United States called Glacier National Park. Within 25 years, it will have to be renamed Glacierless National Park, because the glaciers are melting, receding so rapidly there. And this has consequences, because there's a couple billion people who depend for fresh water on rivers which originate in the mountains, where melting glaciers in the dry months, the hot months of the season, have more than half of their water coming from melting ice. So once those glaciers are gone, you will have bigger floods in the spring as the snow melts, but you will have seasons in which the rivers are tending to run dry. Another effect of global warming and increasing carbon dioxide is on coral reefs, which are under stress for several reasons, but two of the more important ones are the increasing ocean temperature, which can cause the corals to bleach, and the acidification of the ocean. Those species that have carbonate shells or carbonate skeletons cannot survive as the ocean becomes too acid. It will dissolve the carbonates. So looking at all these different sorts of evidence for what would be the safe level of atmospheric carbon dioxide, we come to the conclusion that it's no more than 350 parts per million. And one of the most important ways of concluding that is just looking at the radiation balance of the planet. The increasing CO2 causes the planet to emit less radiation in the infrared part of the spectrum because it makes the atmosphere more opaque for the infrared radiation, so the emission comes from a higher altitude where it's colder. And that the amount of energy coming in from the sun is unchanged by the added CO2. And so you get a planetary energy imbalance with more energy coming in than going out. And where does that energy go? It goes mostly into the ocean because that's where the large thermal inertia is. And now, and this is so if we want to restore the planet's energy balance, well, we know from measuring the rate at which the ocean is accumulating heat that that imbalance is about 3/4 of a watt. If we wanted to restore the planet's energy balance and stabilize the climate, we would need to reduce the CO2 and other gases enough that it increased the emission to space by 3/4 of a watt. And that implies that CO2 would have to be less than 350 parts per million. So if we want to preserve the planet that has existed the last several thousand years during this relatively stable climate of the Holocene, we would need to reduce CO2 then to less than 350 parts per million. And I wanted to mention the fact that the science has actually become much clearer in the last half year or so. One of the things, when I wrote the book, I could only say that it seemed that the planet was out of balance by at least half a watt, or approximately half a watt, based on the measurements of the ocean. But in fact, what our model said was it should have been out of balance by about 3/4 of a watt. Recently, the results from the measurements of the Argo floats, they're beginning early this decade. The different nations of the world began to put out these floats, which, and there are now a couple thousand of them. Every so often, they release an instrument package on a wire, which yo-yos down into the ocean to a depth of 2 kilometers, and then it yo-yos back up. And it measures the temperature of the ocean and the salinity and some other quantities, but it allows us for the first time to see how the heat content of the ocean is changing. And it turns out that it's gaining energy at a rate of about 3/4 of a watt per meter squared. So it makes this, and this is really the smoking gun for proving that humans are the cause of the climate change. Because if this were a natural fluctuation, say the ocean just, its circulation changed so warmer water came to the surface, well then you would get more radiation to space, not less. So it shows that it is a forced climate change. And we know the natural forcings. We're measuring the sun's brightness very precisely, and we know the volcanic aerosols in the stratosphere. So in fact, it is, it's exactly what we calculate it should be. So it really is a confirmation of the basic phenomena. The ice sheet mass balance, I already mentioned that ice sheets are losing mass more and more rapidly. At the time I wrote the book, I didn't know that the curve was actually turning down. And at the time I wrote the book, I had to say that we were stuck. We had been stuck for a couple of years in the deepest solar minimum during the entire period of measurements from the 1970s to the present. And it wasn't certain that the sun would come back out. The sun has this 10 to 12 year cycle in its brightness. But there were times earlier, the Maunder minimum in the Middle Ages, not the Middle Ages, the 1600s, when the Little Ice Age time, when the sun did stay in a minimum for a few decades, and that was presumably at least a major cause of that cool temperatures. Well, but the size of that climate forcing we can compare very accurately to CO2, and even if it stayed in that minimum, it would be equivalent to about 7 years increase in CO2. So it wouldn't change the fact that the planet is going to keep getting warmer if we keep emitting CO2. But it would have reduced the rate. But now what we see is the sun is indeed coming out of its solar minimum. It's going to be a normal, apparently, solar cycle. Okay, so we could get back to 350 parts per million, but what we need to do is look at where this CO2 is coming from. Coming from oil, gas, and coal. Oil and gas are already, we've used a significant fraction of how much is estimated to remain in the ground. There are some uncertainty as to how much remains to be discovered. Coal, again, there's uncertainty about how much there is, but there's enough to cause us to have incredible climate changes. Now, the one, looking at it from a global standpoint, you may not think so from Australia's perspective, but coal is the one thing that could be left in the ground. The oil and gas are owned mainly by Russia and Saudi Arabia. They are, and we're using them at a rate that clearly we're going to use the large pools of oil that are existing are going to be burned. But if we phased out coal use over the next 20 years, then the CO2 amount would peak and begin to decline at about by the middle of the century, depending upon how big these reservoirs of oil and gas are. And with improved forestry and agricultural practices, we could draw down the amount of CO2 in the atmosphere back below 350 parts per million this century. So it's technically feasible if we phased out coal rapidly. But it also means that we could not burn unconventional fossil fuels like tar sands and tar shale. And in order to get back to 350 at a reasonable time, we also should not be going after every last drop of oil in the most extreme environments on the planet. But what's really happening? Well, in the United States, we just signed an agreement with Canada to bring tar sands oil to the United States. And even are developing oil shale, and we're building more coal-fired power plants. And of course, in Australia, they're actually planning to expand the port facility so they can export more coal. So there's no movement in that direction of phasing out coal by any means. There is, in fact, a huge gap between the rhetoric and the reality. The political leaders say that we have a planet in peril and we need to take actions to deal with that, but in fact the actions don't correspond to that at all. It's more a case of greenwash, where they say the right words, but nobody will stand up and say exactly what is really needed in order to solve the problem. And the Kyoto Protocol, for example, the emissions were 1.5% per year before 1997. After that, they've been increasing 3% per year. And Copenhagen was talking about the same type of scheme. So here's the emissions, and you can see that the rate of growth in this decade has been much higher than previously. The problem is, and this is the most fundamental point, as long as fossil fuels are the cheapest energy, we're going to continue to use them. And we're just kidding ourselves that we can put a cap, that any cap has any effect. The reason that they're the cheapest energy is we don't, first of all, we subsidize them in many cases. And secondly, we don't make them pay for their costs to society, to the damage they do to human health, to the environment, and to the future that will be inherited by our children. So the solution, the only solution that's going to work is to put a gradually rising price on carbon emissions. And you also, you need to have efficiency regulations, and you need to have technology development so there's some alternatives. But the most important thing is the price on carbon, because that's what will drive the technology development. Entrepreneurs are not eager to develop something as long as there's cheaper fossil fuels available. So what I say is we need to put a fee. It has to be a very simple system, not the kind of convoluted things which the special interests are able to torque in their favor. But just put a fee across the board on carbon at oil, coal, and gas, and have that fee gradually rising. And the only way the public will allow the fee to rise to a high enough level that it affects their lifestyles and their choices is to have the money not go to special interests and not have Congress decide how they're going to spend this money, but to give the money to the public on a per capita basis. I think it should be mainly in the form of a monthly green check or deposit, electronic deposit to their bank account or debit card. And so the person that uses less than average will actually make money on the process. It could be that some of the money would be given back in the form of a payroll tax deduction, and that's the one experiment where this has been tried in British Columbia. They did it that way. They reduced the payroll taxes, and the public liked it. When the law was passed, within 4 months, it was in effect and working smoothly. And the public re-elected that government when that became the big issue in the next election, because the public liked it. But I think it would actually be sensible to use half of it for payroll tax deduction and half of it for a green check, because half the people are not employed. Either they're retired or they're unemployed for involuntarily, or they're self-employed in a way that they're not on a payroll. You know, for example, in the United States, and Australia and Canada would be very similar, because the use of fossil fuels is almost the same in those 3 countries. By the time the fee gets to the equivalent of $1 a gallon on gasoline, that's, in the United States, it generates a huge amount of money, $670 billion, given our fossil fuel use last year. And it's not, of course, that much in Australia, but per capita, it would be about the same. So it's a lot of money. If you distribute it to legal residents, it's at least a couple of $1,000s per year by the time it gets to that level. And that's beginning to be enough of a price signal that it would affect economic decisions. The fee and dividend has a number of effects. It stimulates the economy. It puts money in the hand of the public. It addresses the fossil fuel addiction, and it solves the climate problem. The cap and trade, there is no way that that can work globally. There's no chance that China and India will accept a cap on their economy. And why should they? Their fossil fuel use is per capita is 10 times less, several times less for China and 20 times less than in India than in the United States or Australia. They're not going to accept a cap, and they've made that very clear. But they are willing to consider a fee, a tax on carbon, which they would collect themselves and, of course, keep the money and decide how they're going to use it. But they don't want to go down the path that the United States did, where we become addicted to fossil fuels and have to protect a supply line around the world with the military. There are other, cap and trade is a system that was designed by big banks because they want to be in this trading business. It'd be a multi-trillion-dollar per year business, and they're going to make money. They've got skilled trading units. And where do their profits come from and their operating costs? They come from increases in the energy price. So the public pays these banks more money. There are other disadvantages. So, on the other hand, a fee and dividend approach it also has it can be made universal, and it can be used. By the way, it requires, in the case of a cap, you need to get 200 countries to agree to it. And what we found is that each country has to be negotiated with. That's why countries like Russia ended up with just a total windfall in the Kyoto Protocol. But with a fee and dividend, with a carbon tax, what's really required is the United States and China to agree, because Europe would certainly go along with it. And then countries that don't want to have a carbon tax, you would put a border tax on products imported from those countries that are made with fossil fuels. And the World Trade Organization already allows that type of border tax. And then those countries actually would quickly agree to a tax because they'd rather collect that money themselves rather than you collecting it from them. So what's the problem? Well, fossil fuels are still the lowest price. We're not able to institute a fee on them. Governments are under the thumb of fossil fuel industry, in my opinion. And there's a revolving door between Washington and Wall Street. There's a revolving door between Congress and lobbyists. Congress people think they have the right to retire and then start to make a lot of money as lobbyists. Unfortunately, money talks in capitals all around the world. And the intergenerational issue, the founding fathers in America understood and considered it self-evident that we use the planet, we're borrowing it from the next generations, and we're obligated to give it to the next generations in equally good condition. Native people talk about the obligations to future generations. And most religious groups feel that there's a duty to preserve creation. Until the public gets involved, it doesn't seem that our government wants to take the actions that are needed. So this is my newest grandchild, getting back to this question of intergenerational inequity. Jake he was 11 months old when I took this photo. He's now 2 years old. So my parents lived to be almost 90 years old, so he will probably be around for most of the century and will feel the full effects of what we do or don't do. What do we do about the situation that we have, which I think has become very clear? We have to try to influence our governments. That's That's not easy because they operate on short election cycles, and they seem to be influenced by the special interests. The courts maybe offer some hope because at least there's a common law that we are enjoying the use of property that belongs to future generations. But that's going to be difficult. I think that the public, this is a moral issue, analogous to some prior cases, the civil rights, and it's probably necessary for the people to get involved and to begin to put more pressure on the government. But as yet, this is pretty far down the line on most people's concerns because of the long time scale of it. I wanted to ask a couple of, I will open it up to questions shortly, but I thought I would ask a couple of questions myself, which are commonly asked. This one was actually asked by the NASA administrator, my boss's boss's boss, who said, on National Public Radio, said, why should we be concerned about human-made climate change? There have been much larger changes during the Earth's history. And, of course, that's true. But if you look at those changes, that actually is our best source of information for just how sensitive the climate system is and what the consequences are going to be. For example, yeah, it's true. This is a graph of the temperature, actually the temperature in the deep ocean over the last 65 million years, the Cenozoic era, beginning after the dinosaurs had disappeared. And during the first 30 million years of that period, the planet was so warm there was no ice on the planet, no ice sheets on Antarctica or Greenland. And we know why that was. Changes in the Earth's temperature have to be due either to the amount of energy coming in, or to some changes on the surface, or to some changes within the atmosphere. But we know how the energy coming in changed. The sun is a well-behaved main sequence star, which is burning hydrogen to make helium in the core with nuclear fusion, and it's slowly getting brighter. So 65 million years ago, it was about 0.4% dimmer. Since the Earth absorbs 240 watts of energy from the sun, that means that there was 1 watt per meter squared less heating of the Earth. And it's slowly increasing over that 65 million years. We know that the changes, we know that the continents were not quite in their present positions 65 million years ago, but they were already at about the same latitudes that they are today. So the changes on the surface amount to a forcing only of the order of 1 watt per meter squared. But we know that the carbon dioxide in the atmosphere changed from as small as 170 parts per million to more than 1,000 parts per million. That variation in CO2 is a forcing of more than 10 watts per meter squared. So that is clearly the major cause of the climate changes over that time period. And as the carbon dioxide, it was, and we also know the reason, by the way, why that happened. The amount of carbon dioxide in the atmosphere is determined by the balance between the source of CO2 to the atmosphere, which is volcanoes, and the sink of CO2, which is the weathering process. As the rivers carry sediments to the ocean, the chemical reactions associated with that deposit carbonate sediments on the ocean floor, taking CO2 out of the atmosphere. But the source and the sink at any given time are not necessarily in balance. They depend upon continental drift. The volcanoes occur at the edges of the continents that are moving. And as the continents move and subduct ocean crust beneath them, that metamorphosis of the high pressure and temperature beneath these moving continents converts those ocean sediments into heavier rocks, and in the process emits carbon dioxide through the volcanoes and the springs. But that depends upon where the continents are moving. And in the case 65 million years ago, the one main change was that India was still south of the equator, but it was moving north rapidly at a rate of about 20 centimeters per year. And it was plowing through this Indian Ocean, which had long been the depot center for major rivers of the world. So it was subducting this ocean crust and producing a lot of CO2. And that is why the planet was getting warmer and warmer until India crashed into Asia and began to push up the Himalaya mountains and the Tibetan plateau. And the weathering of those mountains then became a sink for CO2, and the source was diminished once India had reached Asia. And so the planet, as CO2 started decreasing, and the planet cooled off. So the bottom line is that, yeah, the natural processes can cause huge climate changes. At the 50 million years ago, when the planet was much warmer, there were crocodiles in Alaska. It was a much warmer planet. So that these imbalances between the volcanoes and the sink amount to of the order of 1/10,000th of a part per million of CO2 per year. So in a million years, that makes a change of 100 ppm in the CO2. But humans now are increasing CO2 at a rate of 2 ppm per year. So we're now 10,000 times more powerful than the natural geologic changes in atmospheric CO2. So we are in control of future climate. Natural changes are completely overwhelmed by the human-made change from now on. And it also shows us how sensitive the climate is, because at the time Antarctica began to form ice sheets, there was only about 450 or maybe 500 parts per million of CO2 in the atmosphere. So if we burned all the fossil fuels, we would be sending the planet back to the ice-free state. It would take a while to get there. The ice sheets don't melt instantly. But we would have a situation which, as the ice sheets did begin to disintegrate, would be out of control of the people, the young people who will be around when that process starts. So another question that I am asked is, why do I advocate use of nuclear power? And this is the last personal question, then some other people can ask questions. But what I say is that the highest priority needs to be on energy efficiency, and secondly on renewable energies, and only thirdly on the potential for nuclear power, and then fourthly on carbon capture and sequestration. Frankly, there is no such thing as clean coal, and this carbon capture has been used mainly to divert attention from the continued use of coal. But carbon capture is actually a useful technology, because in order to draw down the amount of CO2 in the atmosphere, we can burn biofuels in power plants, capture the CO2 and put that underground and draw down atmospheric CO2. The thing that I wanted to say about nuclear power is that the potential is in the combination of third generation and fourth generation nuclear power. The nuclear power that is used now is second generation nuclear power. These are light water reactors that use water to slow down the neutrons. Those power plants use less than 1% of the energy in the nuclear fuel, the uranium. And third generation is still a light water reactor, but it's safer. It's the kind that will shut down automatically if there's an anomaly, for example, instead of requiring humans to turn it off. So if there's an earthquake or something else, you won't get a disaster. Fourth generation allows the neutrons to move faster, so it can burn all of the nuclear fuel. not more than 99%. So it's more than 100 times more efficient than third generation. And furthermore, it can burn nuclear waste. And so it can solve, it's our best potential solution for the nuclear waste problem. And the thing is, you have to understand, all the evidence that we have, I would be happy to convince otherwise, but all the evidence indicates renewable energies are not going to be enough to provide the world's energies. Certainly not for China and India. Sun and wind are not going to provide all the energy that they need. And even if you look at the greenest countries, say Germany, which has devoted a huge amount of money to renewable energies, to encourage, they're subsidizing wind and solar energy to a high degree, so high that many industries are starting to move out of Germany because electricity prices have become so much higher. And how much of their electricity are they getting from these renewables? Well, now it's 7% averaged over the year. In the middle of the winter, when the wind is blowing strong, they get more than that. But averaged over the year, it's 7%. Maybe they will double or triple that. But so what are they planning to do? The government is planning to build 20 more coal-fired power plants. So the empirical evidence does not suggest that renewables can do the whole job. And the best way, nuclear power is not going away. There are more. China is now building 24 nuclear power plants. And if we want to minimize the danger of weapons-grade material getting in the hands of people, we should have control of the technologies. So it was a bad decision of the Clinton-Gore administration in 1994, just when the experts at Argonne National Laboratory said they had all the elements now to make a fourth-generation nuclear power plant. Then the anti-nuclear people who support the Democratic Party convinced the Clinton-Gore administration to terminate that because the anti-nuclear people were afraid, we're not going to be able to shut down all the nuclear. Well, we're not going to be able to shut down all the nuclear anyhow. So the United States really should have tried to be on top of that technology so that you can have the international agreements and ways to minimize the danger of nuclear power rather than sticking our heads in the sand and allowing, because as far as fourth generation is concerned, there are 6 other countries that already have the technology. So we're not going to wipe it out by stopping it ourselves. And by the way, the nuclear power has the best safety record of any major industry. In the United States, there was an accident, a 3 Mile Island accident, which released radiation to the atmosphere. And the best calculations for the effect of that suggest that there will be about one death, one cancer death, in addition to the several thousand that the people in that region would have had without that release. The exposure to radiation was equivalent to flying back and forth across the country at the altitude that airplanes fly, 2 trips. So, as I say, nuclear can be made safer. So I think it should be on the table. But yet I get these messages all the time, and people are very, they're very not angry messages, people who are very disappointed in me because I say that we have to look at the nuclear option. But as a scientist, it's not my job to say what people want to hear. And it's my job, I think, is to be as objective as I can. But in contrast, this is a graph showing different types of energy in the United States. And it's a graph which Amory Lovins had made in the 1970s. Now, Amory Lovins says that we do not need nuclear power, we do not need coal, we do not need oil, we do not need gas, and we do not need large hydroelectric dams. That we can do everything with energy efficiency and soft renewable energies. That is exactly what everybody wants to hear, and every month Amory gets another award. But the fact is, now, and he gets a lot of credit, and by the way, one other thing, he says you do not need taxes on carbon. Now, and he was right about energy efficiency. He said that the governments were wrong who say that we have to keep using more and more energy at an exponential rate. In fact, energy use in the US has been fairly flat. It's increased, but not nearly at the rate that the government predicted. But the soft energy, renewable energies are still invisible on this graph. 30 years later, you cannot see them. There is a renewable portion, but that renewable portion is large hydropower and some burning of biomass. The dream that soft technologies, and we don't need any of those fossil fuels or nuclear power, the empirical evidence simply does not support that. So it would be nice to tell people what they want to hear, but that's not what the evidence. And I think, you know, if you're making the decision that I will not allow the consideration of nuclear power, I think you need to think about your children and the other species on the planet. And one reason that India and China are planning to go mainly nuclear for their electric power is that they want to clean up their atmosphere and their water. And they don't see any other way to get there. Okay, now I'm open to other questions. Thanks. Oh. Sorry, one final comment. I never want to emphasize this nuclear stuff, but I just keep getting asked about it. My fundamental message is not about nuclear power. It's about the fact that the climate is getting very near tipping points, and secondly, we cannot solve the problem without a simple carbon price. Because then that carbon price will let us choose among efficiencies, renewables, nuclear, and something else. If there may be something that we haven't thought of that we can get our energy from. But it's not going to happen unless there's an economic incentive to develop it. Thanks.
Jim, thanks very much for that talk. I'd like to ask a question in 3 parts, if I may. One is the burning of biomass when we have a chronic problem with food security and soil carbon levels, and whether the algal synthesis couldn't be scaled up in time to overtake the 3rd and the 4th generation biofuels. The second part is when you talk about renewables, could we perhaps look at regional hubs for manufacturing, minerals processing, the whole dirty end of the supply chain, and then look at places like Australia, South Africa. In Australia, we know that we can scale up solar thermal energy. We're pretty damn sure we can scale up geothermal, and we've got a very good marine energy source. And then the third point is on the nuclear side. What about nuclear fuel leasing in Australia, really monitoring I'll say uranium for the time being, going out around the world. We know where it is, and then ultimately bringing back the spent fuel rods for safe storage in Australia. But then also, what about thorium? Because my understanding is that can be scaled up now as well and isn't very easily translated to weapons-grade material.
Okay, so there are several topics there. The one about biomass. Yeah, you have to be careful about biomass. In the United States, we have a terrible political decisions that have been made which are causing us to use corn to make ethanol. And if you look at the total system, we're actually not gaining anything with regard to reducing carbon in that system. And we're using up farmland which should be used for food. And that is causing then the use of more, well, it's causing an increase in food prices all around the world. But there are marginal lands which have been degraded, which can readily be used to grow biofuels in a way that would be helpful. In some cases, it's actually just reforesting and leaving it there. But you could use marginal lands and grow, again, not a monoculture, but crops that can be used for biofuels on land which is not appropriate for food production. And then, as I mentioned earlier, if you use those biofuels in a power plant that captured the CO2, that's one of the ways which we can use to get back below 350 parts per million in CO2. Another of your questions was about, well, you know, I didn't mention the fact that Australia is actually very well situated in a number of ways. If any place can develop solar thermal for electrical power and close to baseload power, it would be Australia, because you've got all this desert area and your latitude is low enough that you've got sunlight essentially all year long. So, if the government would get behind that, I mean, the truth is, right now it's expensive, so it'd have to be subsidized. But if industry knows that there's a rising carbon price, and if you have some government support, I think that is an option which should be looked at. And as an alternative to nuclear power, I frankly am skeptical that it can provide the level of, but there's certainly plenty of sunlight in the Australian desert, so it really should be looked at very hard, and I think the government should be supporting some trial development. At the same time, Australia is very well situated for nuclear power. So the fact that major cities are along the coastline makes it possible to site a nuclear power plant on the coastline where it can get ocean water for cooling. And the thing about nuclear is it just burns, you can't turn it up and down during the day as the demand for electricity varies. But in Australia, there's a need for desalinizing water. And that nuclear power plant, during the times when you don't need it, all of the energy, you can desalinize water. Or you can make hydrogen. I think that in order to have the options available over the next decade or two, when it will become clear, Australia doesn't agree now that they've got to stop their coal, but they're going to agree, I can guarantee you, within a decade or so, because the climate change will become so strongly apparent that it's going to become imperative. And you need to have those options on the table, so you should really be investigating them. There was another part to your question. Thorium, yeah. There's actually, there are two, in addition to uranium, there's actually more thorium, and it should be, it's a potential fuel for nuclear power also, and it's very abundant in India, so there's a great interest there in developing thorium reactors. Next question.
Yes. This is Richard McGuire. Thank you for your presentation. It was a very good case on the need for a carbon price that's increased. However, I wonder if there's, when you said the options for having it come in, it didn't seem that you were very convinced that those were really going to have any realistic possibility. The government, talking with the government, the courts, or the public protest all seem to be pretty weak. So is there another option that you see, or is it the case that you feel that those are not very strong? And the second question is that it appears to me that your projection of the need for nuclear power in industrial countries, particularly like Australia, Germany, so forth, the United States, is assuming that we're going to have the same or increased use of electricity in the future as today, where we are wasting an awful lot of the electricity we use today. It seems to me there could be a case that using a lot less of it overall in the total country, not just per capita or per dollar of production or something like that, would make quite a difference in the need for electrical energy. So it seems like you're moving towards the nuclear option being included is assuming that we will not revisit our lifestyle, our production, everything else.
Okay, so there are two implied questions already, so let me answer those. Actually, I think there is I'm hopeful that the public will understand the difference between cap-and-trade and fee and dividend. Now, that's asking a lot, but I went to Washington to meet with a coalition of religious leaders, Catholic, Jewish, and Protestant, including evangelicals. And we then went and talked with Senator Kerry and some congressmen on Republican and Democratic side. And we're going to put forward a simple people's climate bill, which will be the fee and dividend approach, or fee and green check approach. It makes so much sense, and everybody privately says, yes, that makes much more sense than cap and trade. Well, of course, cap and trade has the banks behind it, and it's got the fossil fuel industry behind it. And in the United States, well, so it's not easy, but I think if we just get, people say, well, the train has left the station, that cap and trade is what people have decided on. Well, I don't think that's necessarily true. And if we just get a little bit of a head of steam, I think maybe we can make people see what actually makes sense. Now, the second thing that you were bringing, was, yeah, of course, I'm assuming, everybody's assuming, as Amory Lovins showed, energy use and electricity use doesn't need to increase exponentially, but to get it to decrease, there's a lot of potential in energy efficiency, but it's the clean form of energy. Electricity is a clean form of energy, and we're even going to have to probably move our vehicles more toward electricity, either hybrids or fully electric. So it's hard, so there's a great need for electricity. And in other parts of the world, developing countries, their electricity needs are going up, even though it is true. We have to emphasize energy efficiency, and that will be emphasized if we have a rising price on carbon. Okay, next question.
A recent study published by World Watch Institute stated that 51% of greenhouse gas comes from the livestock industry. What can individuals do to reduce this? For example, eating less meat or adopt a vegetarian or vegan diet.
51% comes from where?
Livestock industry.
No, that's, that's not true. We know, we're measuring very accurately how much CO2 is being put in the atmosphere by oil, coal, and gas. And that almost all now of the increases in atmospheric greenhouse gases are CO2 from fossil fuel burning. Now, it is true that agriculture and landfills and leaking pipelines and things put a lot of methane in the atmosphere, but methane has almost stabilized in its amount. We could gain something. We could actually get methane to decrease if we would reduce the agricultural emissions, the landfill emissions, and the coal mine, the amounts that are, they're actually, some of it is just released to the atmosphere in oil fields. Some of it is flared, but it's these other trace gases are important, and the agricultural and actually agriculture, a lot of the oil and gas and coal are used in relation to agricultural activities. So if you meant the CO2 that's used in the process of farming and things, it is a significant fraction of the fossil fuel use, but the farming process does require energy. It's just that we're going to need to find something other than fossil fuels to power the vehicles. Is the next question?
Dr. Hansen, Frank Waller, first of all, thanks very much for coming to Australia. There's a couple of things that questions that I brought up there during the presentation. Number one was we heard mentioned a couple of times 350 parts per million as being the figure that we needed to stabilise the climate. But later on you talked about other factors influencing the climate. I just was wondering if you could clarify how the 350 parts per million per million of carbon dioxide would stabilise the climate. The other part, the other thing that drew my interest was that we hear a lot about the negative consequences of potential climate change, and yet one of the graphs you showed there was had the graph going back to the dinosaur era 65 million years ago. Now, I was taught at school that they died out due to climate change caused by a meteorite or an earthquake or something or other. I forget what it was. But as the end result of that, I think mammals arose, and hence we're standing here having this conversation. So perhaps you could mention any of the positive consequences of climate change. The other thing that drew my attention was.
Okay. Now I forgot the first part of the question. About what? How do I get to 350 ppm?
What is
if we reduce from 390 to 350, that will reduce the planet's energy imbalance by half a watt. We're presently out of balance by about 3/4 of a watt. So that's not quite enough to do the job, but there's potential for decreasing black soot, tropospheric ozone, and methane, all of which we should do for other reasons because they're very health damaging. And so methane indirectly through its effect on tropospheric ozone. And so we can actually calculate pretty well now the changes in the composition that are needed to restore the planet's energy balance, and that's what's needed to stop additional warming. So that's pretty clear. Now, why, of course, for a local people, there can be benefits of warming, and people in Siberia think it's not such a bad idea. Unfortunately, if you look at the Earth, we've been in this remarkable period, and I didn't have time for the paleoclimate lecture, but we've been in this Holocene for close to 12,000 years, which is remarkably a stable sea level and climate. But that was a fairly unusual period to be that long and that with sea level that stable. If we go back to the Pliocene, when it was just 2 degrees warmer, sea level was 25 meters higher. If you go back to when the period we were talking about, 34 million years ago, when sea level was 75 meters higher, and that's, all the cities. We had completely destroyed half of Antiquity, half of the cities, all the coastline cities. So even though it may feel a little better in some place that's a little too cold now, it's not something we could live with. We would be leaving a situation, and it wouldn't happen instantly, but once ice sheets begin to disintegrate, then the situation is out of your control. It's going to be continually changing for centuries as the planet goes toward a new equilibrium. So it's hard to imagine any positive things that would outweigh the negative ones.
My name is Matt Mushalik. I'm a peak oil researcher. And you just mentioned that it will take about 10 years for some climate change events to convince even hardline governments to change their policies. My question is, what kind of climate change events are we likely to see in the next 10 years? And I'm asking this because I see a race between peak oil, the accumulated debt crisis, and the CO2 problem in the atmosphere. And my worst case scenario is that by the time such an event happens and really changes politics, that by that time declining oil production has damaged our financial system and our economy to such an extent we may even have diesel shortages, that actually at that critical moment when there would be political will to do something, we can't do it because we don't have the money and not the diesel to do all the projects to get rid of coal.
Okay, I'm afraid, unfortunately, we're pretty resourceful. And there are ways to squeeze oil out of tar sands and out of tar shale, which actually, there's a huge amount of that stuff. And there's no way we can do that without, sending the planet toward the ice-free state. But that, unfortunately, there are still people, and as I mentioned, our Secretary of State signed an agreement with Canada for a pipeline from the tar sands. So I don't think it's going to be an economic collapse, but I think that there will be a realization that we can't do that. And it's hard to say when that's going to really sink in, because some of these things, they're irregular, and climate trends are a signal which is within a system that has a lot of natural variability. And people still dispute whether these greater extremes that we're seeing are due to climate change, because you can't blame a single event on the climate trend. But as the statistics get more and more overwhelming, and I think what's going to happen is, I'm afraid that this is what's going to happen, that curve that I showed you for the ice sheets beginning to lose mass faster, I'm afraid is going to go down even faster. And then it becomes undeniable that we're sending, and again, it's not because sea level will be going up that fast. Right now it's going up 3.2 centimeters per decade, which is beginning to cause problems in some island nations and things. But what will be clear is that these ice sheets are unstable, and the disasters associated with them will be, unbearable. So we'll have to try to do something about reducing our emissions. There could be other things. It's hard to predict short-term fluctuations in climate. But, okay.
Dr. Hansen, thanks for an interesting talk. As I understand it, the world has been warming since the Little Ice Age in the early 1800s, and it's been 3 periods of warming as rapid as from 1970 through to 2000, in the late 1800s, and also 1930 to 1950. Now, carbon dioxide cannot presumably be attributable to all that warming, so why are we giving it all the blame now, and what else is going on?
Let's see if I have any charts on that. Well, for example, yeah, there was warming, as you mentioned, from early in 1900 to 1940 was not quite as steep as the warming in the last few decades. At that the first half of the century, we were getting, CO2 was increasing more slowly than it is now. There was more of really up until 1970s, there was a competition between positive and negative human-made forcings, the greenhouse gases and the tropospheric aerosols. It's true that in the Little Ice Age was cooler, and there was warming after that. But now, only in the last few decades has the rate of growth of greenhouse gases reached such a magnitude that it's really overwhelming natural fluctuations due to volcanoes and the type of solar variations that contributed to the Little Ice Age a few hundred years ago. And we're measuring these other forcings. We're measuring the solar irradiance changes, and they amount to about 1/4 of a watt per meter squared from the max to the min of the solar cycle. And that's not negligible. The greenhouse gas forcing is now close to 3 watts, but it's balanced by aerosol forcing of minus 1.5 watts. So the net forcing is about 1.5 watts, but half of that has been used up in causing this warming. So the net imbalance of the planet is now about 3/4 of a watt, which compares to this solar variation of 1/4 of a watt. So the solar variation is not negligible, but it's smaller than the greenhouse gas remaining forcing. So other factors are important, but humans have taken over as the dominant factor.
Jim, I was explaining to my 6-year-old daughter why I had to be away tonight, and the simplest way I could put it was to say, well, you're my hero. The reason I said that is because as a scientist, you're one of the rare breed that have actually stepped out of your shell and taken responsibility for the implications of the message that you bear for the planet, and responsibility for the world doing something about it instead of staying within your small niche and hoping that the rest of the world would follow. My questions are... And particularly in the light of the recent rebound of magical thinking, or skepticism, if you want to call it that, which it isn't obviously, in the last 6 months, there's a call for more scientists to do the same. And I'm wondering whether you, what is it about you, do you think, that's different? Because there are a lot of climate scientists that haven't spoken out and taken that leap. And do you have a message for your colleagues, and particularly here in Australia, I guess, the scientists that aren't yet maybe as vocal as they could be in educating the public, or putting their policy implications out there?
I think that other scientists have tried to contribute via the organizations, and you can see why they prefer, like IPCC and the professional organizations. And you can see why, because, now even now, just the last few months, I've been getting a lot of flack or friendly letters from people like John Kerry, for example, who even the politicians say, well, you're a good scientist, but why, you may not understand how politics works. But see, I think what I concluded a few years ago is that unless scientists connect the dots all the way to the implications of the science for policy, that those final few dots will be connected by the special interests. And so I think scientists can try to be objective, and it seems to me that it's useful for scientists to try to connect all of the dots. But you can see that I mean, now I'm spending half my time responding to freedom of information requests because their right-wing organizations are determined to put me in the same boat as Phil Jones and the people who've been criticized for loose statements in emails. And they're hoping they can find some email that I've written sometime that will be embarrassing. And I didn't realize, it took me, I guess so simple-minded, I didn't realize that they had people watching our data, waiting to find some error that they could then claim that the whole thing was a hoax. And actually they did find an error in 2007, which was an innocent error, and it affected global temperature by 0.003 degrees, and the United States temperature by somewhat more than that. Because there was, anyway, I won't explain the details, but it was the fact that an inconsistency between two of the data sets that were coming into our program. But so we now publish our data completely, and we have published and made available on our website the computer program that analyzes it. So it's pretty hard for them. Well, anyway, I think when other scientists look at the trouble that this causes, it can cause them to have second thoughts about speaking out too much. It's really unfortunate because the media did such a crummy job of not recognizing the difference. In the olden days, in the 1970s, the New York Times had Walter Sullivan as a science writer. If there had been some questions, some contrarians, making some claims, then he would call up the top scientists and ask them, what is the real story? Well, instead now, it's presented in the media as any contrarian is equal to any other scientist. And all you would have to do is ask the National Academy of Sciences, what is the story? And is this a hoax or is this real science? And they would give you a very clear answer. And yet the media is presenting it as if there is a big issue. So it's become difficult. It's almost surreal what's happened in the last 6 months. I couldn't have believed that this gap between what was understood and what was known would actually get bigger, but it got dramatically bigger. And it may be partly because the public is more comfortable thinking that maybe this is a hoax, so we can forget about it.
2 quick points. Michael Stoltz. In 1800, the world population was 1 billion. If the current world population grows by 1.2% in 750 years, there would be 1 person per 1 square kilometer. Of course, we won't get to that, but it's far away in the future. But 750 years back was only in the Middle Ages. So you didn't mention 2 things. One is population, which is actually responsible for the current climate warming. And the other thing is last year the world economy only grew by 0.5%, and we were in deep shit. We need a different system, obviously, in that area too.
Yeah, that's a good point. Population should be mentioned, and it is briefly discussed in my book. If population just keeps going, it's very hard to solve the problem. The encouraging thing is that in developed countries, the fertility rate in most of them is below replacement level, and generally, as countries become wealthier, that tends to be the true. And also, women are worldwide, even in countries that are not developed, having many children is becoming less popular. So the population is still going up because life expectancy continues to increase. But we need to take steps to address that. And one of the things that I didn't mention, it was on one of my charts, was that if you have a fee and dividend system, those countries, the developing countries who may not place a fee on fossil fuels, the money that you collect from the import duties should be used, not given, I think, go back to the developing countries, and it should not necessarily, it should not go back just to wherever it came from. It should go preferentially to the countries that have practices like women's education, practices that avoid this runaway population, which is still growing in some parts of the world pretty rapidly. But that is an important point which needs to be considered. Okay, maybe one or two more questions.
You've had a couple of painful decades watching politicians ignore scientists, and you've just described how over that time the media, which politicians obviously pay a lot of attention to, has gotten worse. I was interested in your comment earlier on Winston Churchill, that we are still waiting for our Winston Churchill. And I think a lot of Americans and Australians were hoping that Obama and Rudd would play that role. And instead of them fighting the free-riding polluters on the beaches, they've been spending a lot of political energy in justifying the appeasement in their policies. So do you think that it's a Winston Churchill that we need? Do you think that it is just the fact that we haven't had the equivalent of bombs falling on houses, and maybe in the next decade, as the solar minimum isn't there anymore, we'll have some catalytic event like the, upswing in Arctic sea ice melting? What is it, do you think, that will take it over? Or is it that we actually don't have the kind of politics that can produce a Churchill?
Winston Churchill had it easier because they saw the threat across the channel, and so you could rally the people when the Germans started bombing and things. So, but yeah, we're disappointed in Obama, which was most evident in the State of the Union message not long ago. When he got to the climate subject, it consisted of a sentence or two in which he started out saying, I know many of you don't believe in global warming, at which point there was a huge applause from many of the people, the senators and representatives, and he kind of had a smirk on his face, and it's, the thing is, this is not a belief. It's not a matter of a belief. In the Middle Ages, and when Galileo had to confess that the sun really goes around the earth, not the earth going around the sun, because the Catholic belief was that the earth was the center of the universe, that was a matter of belief overwhelming scientific fact. But we can't let belief overwhelm the scientific fact now, because we're cheating our children and grandchildren. And Obama should have used the moment to say what the situation is, and we've got to do something, and unfortunately he didn't do that. Now, he's still our best hope at this point, if amongst politicians, I think, but he does. But you can't fully blame him, because what is the advice he's getting? The advice he's getting is cap and trade, and that's what he's allowing Congress and the lobbyists to define the system. You'd rather have a stronger leader who would say, these are the boundary conditions, you need to define something within these parameters. But then he needs to be advised by his people on what is needed. And as long as they're telling him cap and trade and offsets is okay, then you can see the hokey thing that comes out of this. These bills in Congress amount to almost nothing in terms of reductions. They're mostly, they're very small changes. So I don't know, but I still, the priorities in the administration clearly were different. They had an economy collapsing when he came into office. There was a danger of really a depression type situation. And then there's the healthcare issue, which was his priority. Maybe if he turns his attention to this, maybe they can see that we need a different approach. I don't know. Okay, maybe one more question.
I just have Simon Butler from Greenland Weekly. I've got a question about your carbon tax proposal, and I want to thank you for explaining it tonight. My view is that a high price of carbon is better than a low one. But I wanted to ask about the dividend. And in your book and tonight, you've explained that it should really go straight back to people. I question that because there's also a pressing need, if you're going to phase out fossil fuels, to actually have infrastructure built to replace it. So shouldn't the tax on the polluters, shouldn't that go substantially into funding the transition to renewables? Shouldn't that be the essence of a carbon tax?
I don't think so. I don't think so, because the government never invests wisely. They never make the right. And besides, they don't invest that much compared to the investments from the private sector. If private sector sees that carbon price is going up, they will make investments. Now, the government does have to do some things. It's going to have to, help with the siting of transmission lines and do some things to encourage or partially subsidize some things. But I don't think but the government already has a lot of money. They're already taxing people pretty heavily. In the United States, the Energy Department has a pretty big budget. So I think that the public, this money from increased price for fossil fuel carbon emissions, I think should go 100% to the public, and that will stimulate the economy, and it will stimulate innovations, and yeah, the government also is spending lots of money on infrastructure and needs to do it in ways that aid these developing possibilities. But I think the dividend should go back to the public. That's the only way they will let it rise to the level that's needed to really affect lifestyle choices. Okay, maybe one more.
Given the warming already in the climate system that we're committed to, effectively, do you feel that there's a possibility that we may have gone over some of the climatic tipping points that you speak of?
There's a danger that we've done that. In the case of the ice sheets, that's the one. And in the case of the Arctic sea ice, we're likely to lose the Arctic sea ice, but that is a reversible tipping point. If you restore the planet's energy balance, the ice can reform. But the ice sheets is not a reversible one on any time scale we can imagine. It would take thousands of years to build an ice sheet. So that's a danger, that we are going to get a significant sea level rise, even if we start to slow down the emissions pretty rapidly. But there's a big difference between a sea level rise of 1 meter or so and a sea level rise of 25 meters. So we can't give up just because we're going to get some substantial change. So, and maybe it's more than 1 meter or so. But anyway, we don't know that. By definition, nonlinear processes, tipping point type processes where suddenly you go off an edge and the dynamics takes over, that's impossible. Very difficult to quantitatively predict ahead of time. Thanks.